Hello everyone, I Dr. Smita Rani Bhardia will discuss here about the fire hydrant system. It is part of module 6 and lecture number 21. Purpose and importance of fire hydrant systems. Fire hydrant systems play a crucial role in securing public safety and protecting properties from devastating effect of fires. These systems are strategically designed and distributed throughout urban and industrial areas to provide readily available source of water for firefighting operations. We will discuss into the purpose and importance of fire hydrant system in more detail. First, immediately access to water. One of the primary purpose of fire hydrant system is to provide immediately access to a substantial and pressurized water supply. This quick access to water is vital during the early stage of a fire when every second counts. Firefighters can connect their hoses to hydrant, allowing them to readily suppress flame and prevent the fire from spreading further. Second one is support for firefighting operations. Fire hydrants are critical tools for firefighters, serving as a key component in fire suspension strategies. They ensure a dependable and consistent water supply, allowing firefighters to focus on extinguishing fires rather than worrying about securing water sources. This can be significantly enhances the effectiveness and efficiency of firefighting efforts. Third one is supplementing fire suspension system. While many buildings are equipped with their own fire suspension system, such as sprinklers, this system may not always be sufficient to control a large fire. Fire hydrant systems serve as a backup water sources, providing additional water volume and pressure when needed. Fourth one is protection of property and lives. Fire hydrant systems are instrumental in protecting both properties and lives. By enabling rapid fire responses, they help prevent fires from spreading and causing more extensive damage. This is particularly important in densely populated urban areas where fire can quickly accelerate and pose several threats to residents, business and infrastructures. Fifth one is critical infrastructure protection. Sixth one is supporting large scale incidents, and seventh is insecuring and regulatory compliances, and furthermore eighth is community resilience. And further we will move about the what are the types of fire hydrant system. Fire hydrant systems come in various types, each designed to meet specific firefighting and water distributions needed. Understanding these types of crucial and selecting the appropriate system for a given applications. Here is a detailed overview of the main type of fire hydrant system. Wet barrel hydrant. Wet barrel hydrants are among the most common type of fire hydrant. They are called wet because water is always present in the barrel just below the rust line. These hydrants are typically found in regions with milder climate where freezing is not a significant concern. Water remains inside the hydrants at the time. Easily access to water as there is no need to open valves to release water. Suitable for areas with low freezing risk. Second one is dry barrel hydrant. Dry barrel hydrant are designed for reasons where freezing temperatures are a concern. Unlike wet barrel hydrant, they do not contain water in barrel. Instead, water is stored below the frost line and the barrel remains dry until it needed. The key features of this wet barrel hydrants are reduced risk and freezing in cold climate. Hydrant must be opened and drained before water can be accessed, and typically used in colder region where freezing is a concern. Private hydrant. Its description is just like private hydrants are installed on private properties such as industrial complexes, shopping centers, or large facilities. They are not part of public water supply system and are maintained by the property owner. If we call about its key feature, it dedicated to water supply for specific properties or facilities. Property owners are responsible for maintenance and compliances, often used in industrial and commercial setting. Next one is public hydrant. If we are talking about the public hydrant, then description is like public hydrant system part of a municipal water supply system and or owned and maintained by the local water authority or fire department. They are typically located along street and in public areas for use by the fire department. The key features of this public water hydrants are the part of the public water distribution center, regularly inspected by and maintenance by municipal authorities, available for use by firefighters and authorized personnel. The next type of fire hydrant system is underground water hydrant. Descriptions are like underground water hydrants are also known as flush hydrant or post hydrants are installed below ground level. Only the top part of hydrant called the bonnet is visible above the ground. Minimal above ground visibility and reduce the risk of damage. Commercially used in urban areas, whereas aesthetics are in concern, may have retractable or removable cap for water access. Above ground hydrants. Above ground hydrants are fully visible and are often painted in distinct color to indicate their water pressure. They are commonly found in suburban and rural areas. Its key features are easily identifiable by firefighters and maintenance personnel, may have different nozzle sizes and pressure rating, typically found in areas with lower population density. Various components of fire hydrant systems. First, a fire hydrant system consists of a various components that work together to provide a reliable source of water for firefighting operations. These components ensure the efficient and controlled distribution of water to fire hoses. Here is a detailed overview of the key component of a fire hydrant system. First one is the main water supply. The main water supply is the source of water for the fire hydrant system. It is typically connected to the municipal water distribution system or a dedicated water supply sources such as reservoir or tank. The main water supply must be capable of delivering sufficient water pressure and flow rate to meet the firefighting needs of the areas it serves. Second one is hydrant body. Hydrant body is the main structure that houses the internal components of the fire hydrant. It is typically made up of durable material such as cast iron or ductile iron to withstand environmental conditions and physical stress. The hydrant body is usually painted in a distinct color, example red or yellow, to make it easily visible for firefighters and maintenance personnel. Hydrant nozzle and couplings. The hydrant nozzle is an outlet through which water is discharged from the hydrant. It is designed to accommodate fire hoses and nozzles securely. Hydrant couplings are standardized connections that allow firefighters to attach hoses to the hydrant nozzle quickly. The size and type of nozzle and couplings may vary depending on local standards and the intended use of the hydrant. Operating valve. The operating valve is a key component that controls the flow and water through the hydrant. It is typically located within the hydrant body and is operated from the exterior. There are two main types of operating valve. One, the main valve and the drain valve. The main valve controls the flow of water to nozzle, while the drain valve is used to release water from the hydrant when it is not in use, preventing freezing in dry barrel hydrant. The fifth part of this is hydrant marking and signage. The fire hydrants are often marked with specific information to provide essential detail to firefighters and maintenance personnel. Common marking including the hydrant's flow rate, pressure rating, and the distance to the main valve. Signage may also indicate a direction of water flow and the type of hydrant, example wet barrel or the dry barrel. Hydrant accessories. Various accessories may be installed on or near the fire hydrant to enhance its functionality. These may include hose cap and chain to protect the nozzle and keep it clean when it's not in use. Hydrant wrenches and tools for the operating and maintaining the hydrants. Traffic markers and reflective tape to make hydrant visible to drivers and emergency responses, especially in low light condition. Locking mechanism to prevent unauthorized use or tampering with the hydrant. Pressure reducing valve. It's an optional. In some cases, pressure reducing valves may be installed on fire hydrants to control the water pressure delivered to the nozzle. These valves are particularly useful in the areas with high water pressure to prevent hose damage and excessive water discharge. Understanding these components and their function is essential for the proper installation, operation and maintenance of a fire hydrant system. Regular inspection and maintenance are crucial to ensuring that the components are in working order and the system is ready to provide an immediate and reliable source of water for firefighting purpose when it needed. Hydrant system design of fire hydrant system. Designing of a fire hydrant system is a complex process that involves considering various factors to ensure that the system will provide an adequate and reliable water supply for firefighting operations. Here's a detailed overview of the key aspects to consider the firefighters to consider in the design of a firefighting system. We will discuss here some, but I will tell you all the name. What are the main system? First is location and spacing. Determine the optional location for the fire hydrant based on local regulations and standard. Hydrants should be strategically placed to ensure adequate coverage and accessibility for firefighting personnel. Consider factors such as proximity to building, roadways, and high risk area. Second one is water supply capacity. Calculate the required water supply capacity based on factors such as the size and type of structures to be protected, potential fire hazards, and local fire flow requirement. Ensure that the water supply can be delivered sufficient flow rates and pressure to meet firefighting needed. Third one is pipe sizing and layout. Design the water distribution network including the underground piping that connect the hydrant to the water supply sources. Pipe sizing should account for friction losses, elevation changes and system demand. Lay out the pipe in a grid or network that provides even coverage and minimizes dead end section. The fourth one is pressure requirement. Determine the minimum and maximum allowable operating pressure for the hydrant system. Pressure requirement can vary based on local regulations and the need of the fire department. Use pressure reducing valve if the necessary to control high water pressure and prevent hose damage. Fifth one is backflow prevention. Implement backflow prevention measures to ensure that contaminated water does not enter the public water supply through the fire hydrant system. This is critical to maintain water quantity and public health. Install backflow prevention device such as backflow prevention and check valve at appropriate locations. Sixth one is hydrant type and specification. Select the appropriate type of hydrant, example wet barrel or dry barrel, based on the local climate, conditions and freezing risk. Specify the required nozzle size, coupling and pressure rating for each hydrant based on the anticipated firefighting needs. Seventh one is accessibility and cleanness. Ensuring that the fire hydrants are easily accessible to firefighting equipment such as fire trucks. Maintenance clearness around hydrants to allow unobstructed operations and visibility. Consider local regulations regarding hydrant clearness and visibility requirement. Eighth one is traffic consideration. Evaluated traffic flow and road design near hydrant locations. Implement traffic management measures such as reflective markers and signage to prevent obstruction of hydrants. Ensure that the hydrants do not impede emergency vehicle access. Regulatory compliances. Familiarizes yourself with local, state and national regulation and standard governing fire hydrant design. Comply with these requirements to ensure that the system is safe and meets local obligations. Fire department coordination. Collaboration with the local fire department to ensure that the hydrant systems meet their operational need and preferences. Firefighters should be trained in the use and location of hydrants. The last one is testing and commissioning. Conduct throughout testing and commissioning of the hydrant system before it is put into service. This includes flow testing, pressure testing and ensuring that the components operated as intended. Documentation and record keeping. Maintain detailed record of the hydrant system design, installation, testing and maintenance activities. These records are essential for ongoing system management and compliance. Further expansion and upgrades. Consider the potential needed for system expansion or upgraded as the area develop or fire protection requirements change. Plan for further expansion and flexibility in system design. The design of a fire hydrant system requires careful consideration of these factors to ensure that the system is capable of delivering an immediate and reliable water supply for firefighting purpose. Collaboration with relevant authorities throughout planning and adherence to best practices and regulations are essential for a successful hydrant system design. The maintenance required for fire hydrant system is regular inspection, lubrication, flow testing, paint and marking, operational testing, backflow prevention device, inspection, repair and upgrades, documentations, winterization, that is only for dry barrel hydrant, training and awareness, effective installation and maintenance practices are essential for ensuring the longevity and reliability of a fire hydrant system. Regular inspection and protective maintenance help identify and address potential issues before they become critical, ensuring that the system is always prepared to provide water for firefighting in emergencies. The regulatory compliances of fire hydrant system. Regulatory compliances for fire hydrant system is essential to ensure that these critical firefighting assets are properly designed, installed, maintained and utilized to safeguard life and property during the fire emergencies. Compliances with regularity standards help standardize practices and maintain in the integrity of the fire hydrant system. Below are some of the key aspects of regulatory compliances for fire hydrant system. First one is National Fire Protection Association standards. NFPA is a prominent organization that develops and publishes standards and codes related to the fire safety, including standards for fire hydrant system. The primary NFPA standard governing fire hydrant in is NFPA 24, a standard for the installation of private fire service main and their appetances. NFPA 24 provides comprehensive guidelines for the installation, testing and maintenance of private fire service main including hydrant. Second one is Local Building Code and Regulations. Municipalities, states and local authorities often have their own building code, fire code and regulatory that specify requirement for fire hydrant system. These regulatory may vary by jurisdiction, so it is crucial to comply with the specific code application to location where the hydrant system is installed. Third, Water Authority Regulation. Water authorities or utilizers may have their own rules and regulations governing the installation and maintenance of the fire hydrant system. Compliances with these regulations is essential because the water utility is often responsible for the providing water supply to the water hydrant system. There are so many, just like accessibility and visibility, maintenance and inspection schedules, pressure and flow requirement. I will discuss about it. It is crucial to work closely with the local authorities, fire departments, and relevant agencies to ensure that the fire hydrant systems meet all applicable regularities and requirement. Regular communication adheres to codes and standard and proper documentation of compliances efforts are essential for the successful implementation and maintenance of fire hydrant system. What are the emergency responses and firefighting emergency responses? Emergency responses refers to action and strategies employed to control and mitigate emergencies with a primary focus on combating fires. These activities are carried out by trained professionals such as firefighters to protect lives, protect properties, and the environment. Here is a breakdown of key components of emergency responses and firefighting. First is fire suspension, search and rescue, medical aid, hazard mitigation, evacuation and sheltering, traffic control, scene management. The role of fire hydrant in the firefighting. Fire hydrants play a crucial role in providing a reliable and immediate source of water for firefighting operations. Their primary functions in firefighting includes water supply. Fire hydrants are connected to the municipal water distribution system or the other water sources. They provide a readily available and pressurized water supply for firefighting efforts, eliminating the need for firefighting to rely solely on onboard water tank in fire tank truck. Accessibility. Fire hydrants are strategically placed throughout communities to ensure easy access for firefighting equipment. Their locations are planned to minimize response time and maximize coverage. Water distribution. Fire hydrants are interconnected through a network of water underground pipes, allowing firefighters to stabilize multiple water supply points for a fire incident. This distribution system ensures that water can be directed to various parts of fire scene. Fourth one is flow control. Firefighters can control the flow rate and pressure of water from hydrant to match the specific firefighting needs. This control is crucial for managing the intensity and direction of water streams during fire suspension efforts. Continuous water supply. Unlike on-board water tank in fire truck, which have limited capacities, fire hydrant provides a continuous water supply. This allows firefighters to maintain a steady stream of water for extended firefighting operations without the need of frequent refilling. 6 is backup and redundancy. Fire hydrant serves as a critical backup water source in class where natural water bodies such as a lake or pond may not be readily available or sufficient for firefighting. They offer redundancy to ensure a reliable water supply. The fire hydrants are essential components of firefighting infrastructure. They ensure that the firefighters have immediate access to a consistent and pressurized water source, allowing them to effectively and efficiently combat fire and protect lives and properties during emergency responses operations. What kind of functions should be included in the future trend in fire hydrant system? The future trend in fire hydrant system are expected to incorporate the advancement in the technology, material and design to enhance and effectiveness, reliability and efficiency of these critical firefighting assets. Here are some potential future trends in fire hydrant system. First is a smart hydrant system. Integration of a smart technology into hydrant to enable remote monitoring and control. A smart hydrant can provide real-time data on the water pressure, flow rates and system status. This data can be transmitted to central monitoring station, improving incidents and response and maintenance. Second one is leak detection and early warning system. Incorporation of leak detection sensor and early warning system to identify and alert authorities to leak or damage in the hydrant system. This protective approach can help prevent water losses and maintain system integrity. Third one is water quality monitoring. Implementation of water quality monitoring sensor to ensure that the water supply from hydrant remain free contaminant. This is especially important to prevent backflow related issue. There are so many we can include. Next is enhanced material and corrosion resistance, energy efficient system, hydraulic modeling and stimulation, automatic flow testing, improved backflow prevention, water recycling and reuses, climate adaptation, distributed water supply network, printing and modeling component, green infrastructure integration, hybrid firefighting technologies and training and stimulations. These future trends in fire hydrant system aims to address involving challenge, enhances system performance and promote sustainability in firefighting infrastructure. The integration of smart technologies, improved material and innovative design concept is expected to contribute to more effective fire protection and emergency responses. In the closing, it is evident that fire hydrant systems are not just an unassuming fixture on your street. They are the unsung heroes of fire protection and emergency responses. Throughout this preventions, we have explored the purpose and types, components, design, consideration, maintenance, and future trends of fire hydrant system. It is crucial to remember that the fire hydrants are not mere utilizers but lifeline during emergencies. They stand as a silent sentinels and ready to deliver the life-giving forces of water when need arises. Their importance cannot be overstated as they are the linchpin of effective firefighting, helping us safeguard lives, properties, and the environment. As we have concluded, let's take away a few key points. First, fire hydrants are strategically placed throughout our communities to provide firefighters with rapid and reliable access to water during emergency. Proper maintenance and regulation testing of fire hydrant systems are essential to ensure their operational readiness. Compliances with the regulatory standards and the integration of technologies are shaping the future of fire hydrant systems, making them smarter, more efficient, and environmentally responsible. Fire hydrants are a symbol of our commitment to safety and they embody the direct dedication of firefighters and emergency responder to protect and serve our communities. Let us recognize their importance and support effect to ensure that these vital systems remain ready to respond whenever the call for help comes. Thank you for your attention, and let us all continue to work together to our fire protection infrastructure and ensure a safe, more resilient future. In next our lecture, we will discuss about the fire rescue tender. Thank you so much.